Okay, now this actually is not really one of the cases here, because in this case both m and n are odd. So I have sine of x squared quantity cubed, so the sine power is odd, and I have cosine x squared quantity fifth, so the cosine power is odd. Now if both m and n are odd, you can actually elect either case, case 1 or case 2. So that's what we're going to do here. So let's see which case I elect. Before I elect a case, I want to get this x squared written as a single variable like theta. So I'm going to let theta equal x squared. Then d theta would be 2x dx. So notice it's a good thing that I have this 2x right here. So now I know that the 2x along with the dx will be d theta. So then I can write this as sine of theta cubed times cosine of theta to the fifth power, and then the 2x dx is the d theta. Okay, now as I said, we could use either case here, but I'm going to go ahead and use case 2. So what I'm going to do is I'm going to write I'm going to think of, instead of cosine fifth theta, now I did two things at once here, so kind of stay with me right here. Okay, so think of cosine fifth theta as cosine fourth theta times cosine theta. So in other words, if I factor a cosine theta out of this, I'll get a cosine theta to go with the d theta. Okay, but what would I be left with if I factored a cosine theta out of this? I'd be left with cosine fourth theta. And cosine fourth theta can be written as cosine squared theta squared. Right? Cosine squared theta quantity squared. Then I can do my little trick where I replace cosine squared theta with 1 minus sine squared theta. So I have 1 minus sine squared theta quantity squared. So now I have sine cubed theta times 1 minus sine squared theta. Sorry about that. Sorry about that. I had the TV on pause there and it just started playing. Okay, but back to where I was. Okay, so sine cubed theta, I have sine cubed theta times 1 minus sine squared theta quantity squared, and then times cosine theta d theta. So now I can let u equal sine theta, and so if I let u equal sine theta, then du is cosine theta d theta. So that means that this right here is just the du, and this would be u cubed, and this would be 1 minus u squared quantity squared. So I actually have right here, I have u cubed times 1 minus u squared quantity squared, and like I said, the cosine theta d theta is the du. So now if I go ahead and square this binomial 1 minus u squared quantity squared, I get 1 minus 2u squared plus u to the fourth, and then I can multiply that by u cubed, and I'll get u cubed minus 2 times u to the fifth plus u to the seventh du, and then when I integrate this, I get u to the fourth over 4 minus 2u to the 6 over 6 plus u to the 8th over 8. Now in the next step, I'm going to go ahead and replace the u with the substitution I used right here, sine theta. So I'm going to get sine fourth theta over 4, and here I'm going to get minus sine of theta to the 6th power over 3, and that's because 2 over 6 reduces to 1/3. And then on the last term, I get sine of theta to the 8th power over 8. And then, of course, don't forget your constant. And then there is one last step. I have to do my final replacement here for theta. Remember, up there at the top, I let theta equal x squared. So I replace theta with x squared, and I get sine of x squared to the 4th power over 4 plus sine of x squared to the 6th power over 3 plus sine of x squared to the 8th power over 8 plus a constant. So there's your final answer right here, and that's how you deal with it if both m and n are odd. Now there's a couple of examples down here that you can practice on if you want to freeze the video and copy those down, and I've got the answers given for you there. Okay, so in the next video I'm going to deal, as you can see down here, I'm going to deal with powers of tangents and secants, and I'll show you how to deal with powers of tangents and secants in the next video.